Before we begin, let me just maybe hand over the word already to my co-host Carsten on the disclaimers, which we'll have with here.
Thank you, Beat. Yeah, just very briefly, because we are going to have some slides on some things that are not GA yet. So I'm basically forced to show you the safe harbor and the disclaimers. I think you've all seen that so many times, so I think we're good to go to the next slide.
All right, so maybe we'll just continue with the introduction of ourselves then. My name is Beat Panwart. I'm product manager at 2150 Datavault Builder AG. I'm mainly responsible in bringing feedback from customers, from clients into the continuous application improvement. And I'm very proud that with me here today is Carsten Weidmann. Maybe you can introduce yourself.
Thank you, Beat. Yeah, Carsten Weidmann. I'm a partner sales engineer for working for Snowflake. As a partner sales engineer, I take care of all our data cloud product partners, such as Datavault Builder in the EMEA region, and I'm more than happy today to support Beat in this webinar and demonstrate how Datavault Builder runs on Snowpark Container Services.
Excellent. So let me just start out just briefly giving you a 2 to 4 minute introduction to Datavault Builder if you have never really worked with Datavault Builder in the past. So Datavault Builder offers an end-to-end data warehouse automation solution. So that means what we see here on this slides is a general layer architecture of a data warehouse. So you have a staging layer, you have a core warehouse layer where you then persist the data, and then you also have data mart layers, which then prepare the data for data output. So apply the business logic to it to really prepare the data for data marts. And Datavault Builder supports in this flow, so you can start on collaborating to create the core business model. And then once you have this core business model, we have built-in features to then actually bring in the data into this model. So we have a staging module built in, which allows us to connect the different sources, to extract the data, and to then also load this data into the core warehouse layer. As well then, once we have this data historized and persisted, we can design then specific interfaces for different target applications so that the data is afterwards ready to be published and consumed by the target data consumers. So instead of having the setup of a landscape where you have multiple different toolings in place, where you have a modeling tool, an orchestrator, a documentation, some are generated separately or needing to be maintained separately. That's basically all built into Datavault Builder. So Datavault Builder does not just do this modeling part and code generation part, but it also comes with features to then deploy changes, to integrate this with the Git-based deployment process. It has APIs to also then run CI/CD pipelines to actually bring changes from one environment onto another one in an automated manner. And it also has built-in features to then orchestrate the loads. It has an operations module built in to parallelize loading processes and also to schedule loading processes. So that means it's really a fully fledged solution to not only create the data models, but also to create the data flows and also run those data flows for your data warehouse. And how do we do this? Technically, the architecture, it's very simplified terms, 2 parts. So one is Datavault Builder, and the second important part is the database. So whatever Datavault Builder is doing, it's basically pushing this down onto the database it sits on top of. So whenever we create something in Datavault Builder, when we create structures, it directly creates those structures on the underlying database. And also when it does loading processes, it does perform these loading processes by sending the statements down to the database, which will then actually do the heavy workload. So that means we have two parts, the application part and the database part. And the application part, Datavault Builder itself is stateless. So what it means is it doesn't have a separate metadata repository. It connects to the database, it reads out what is there, and it then represents that state again in the interface. Datavault Builder is shipped as a set of Docker images. If you're not familiar with Docker, it's a virtualization basically on occupation level. And what it allows you, the benefits is you can basically deploy it anywhere where you can run Docker-based images. You can deploy it with Kubernetes, you can deploy it in the cloud or on-prem. And now with Snowflake, Snowpark Container Services, this will also be possible to deploy it directly within Snowflake's infrastructure. And for that part, to give an introduction to Snowflake's Snowpark Container Services, I'll hand over to Carson. Carson, you're on mute.
It's always the same. Thank you, Beat.
Yeah, no worries.
So thank you, Beat. You can go to the next slide, actually. So Snowpark Container Services. What is it? In general, it's basically another type of compute that is now available on Snowflake, on the Snowflake platform. You already know the traditional type of compute, your virtual warehouses, where you could size them in different sizes or use them in different sizes. We then at one point introduced also those Snowpark optimized warehouses, but all these warehouses could do is basically run SQL, right? With some user-defined functions written in Python or JavaScript or whatever, but that was a limitation. And in order to expand the capabilities of what users could do inside Snowflake, we added those Snowpark Container Services, which, as I said, is a different type or another type of compute in different configurations. As you know, with virtual warehouses, you can scale them up and down. In this case, it's different types of CPU, basically, as you would know from Amazon or AWS, the EC2 instances, stuff like that. You can choose between, do I need just CPU instances, or maybe do I also need a GPU instance, which then becomes important when you want to use this additional compute, for example, for Gen AI stuff. It gives you the flexibility to actually use it in many different fashions, many different ways. It implements a Kubernetes-based cluster. That means what we just heard from Beat around Datavault Builder is a set of Docker containers that's exactly made for that. So that basically companies, providers that have their solution already packaged up in a Docker container can very quickly, very easily add these to the platform and make them available for the users, for the clients of our platform to use these services, to use these applications, and to do different things with that. For that, Beat, the next slide, please. So what are typical use cases or workloads, as we call them, that can be executed using Snowpark Container Services? So one very big hot topic, that's of course the AI/ML workloads that you can run then dedicated inference on GPUs or training on GPUs, which was not possible before with our regular warehouses that had just CPUs, but no GPUs available. Of course, with that, adding the possibility to not only use Python as a UDF, but actually any language like R, for example, as well. You can use them for LLMs, which require quite some GPUs actually to execute, to perform. But actually, use your LLM in your own environment. Take an open source one like Llama 2 or whatever version that is, or our internal Arctic, but that's an internal one. But the external open source, something from Hugging Face, add that using Snowpark Container Services, and then use it with your own data, making sure that actually your data never leaves your trusted environment. You can create a RAG from that, add it to the LLM, and then create your own chatbot, for example, or whatever is the case here. Of course, also available for optimized processing whenever you have algorithms that are specifically coded in C, C++. You have some web API you want to access that, but want to run that internally on your own data. That is also possible. And then last but not least, and that's the case for today, it's applications. You can run entire applications within Snowpark Container Services, and that is also something we're going to look at. And if you just flip to the third slide in this thing, it's basically these are the three usage options you have. You can either run it as a service, that would be that application. This is something we're going to look at into a little bit deeper in a bit. A second point would be this ML training inference that is a service function that would then leverage, for example, the GPUs you made available in those instances. And last but not least, you could also create jobs. That means you could run a job on one of these on these containers, or using these containers on SPCS to execute that, and then have long-running jobs that do some training on the GPUs or something like this, and then return the result. So these are basically the three usage options. Today, we're going to look at the service. And with that, I'll hand back to Beat.
Great, thanks. Just almost did the same mistake with unmuting myself. So let's look how we can actually, within minutes, deploy a new environment on Snowflake, Snowpark Container Services. And how do we do this? So basically, if we look at the architecture we had previously from the application of the database, that means that Datavault Builder will actually run within the Snowflake infrastructure right next to the database. And whenever we do also then log into the application, once we are logged in, we are then with our Datavault Builder service already having that communication between the service itself and the database, all secured within Snowflake's environment. So let's just see how the two steps which are necessary essentially to deploy Datavault Builder. So for running an application, the Docker image-based application on Snowpark Container Services, what you need to do once basically is to create image repository or registry on your Snowflake account where you can upload and push the container images into, so that they are afterwards usable for the services which you are creating. What you also need to do is you need to then create access integration. So if you recall the architecture slide from previously, that means we need to allow access to our service from the outside. And then last but not least, service will run on top of a compute pool. So you need to set up at least one compute pool before you can then deploy the service or start the service on that compute pool. And in case of Datavault Builder, what you can also already prepare is a template database. So with Datavault Builder, we have certain structures which basically are required on an empty environment, on an empty install. So we can create just a template database. And this part is not what we're going to show today. So because you're just having to do this part once, what we'll show you today is how we can, once this part is in place, pull up a new environment, so create a new sandbox environment within just a couple of minutes. And what do we do therefore? We will just take this template database, we'll clone it, and then basically we can just run a set of SQL statements to start our service, which will then run Datavault Builder for us. So let's just go into the hands-on part for this. And let's just quickly switch into my browser. And hopefully you can already see my browser now. Otherwise, please shout out.
Yes, I think I can see it.
Great, thanks. So what we have prepared here is essentially template database running Datavault Builder SAM 301, where we have all the necessary schemas for an environment pre-configured. And what we want to do is we want to just essentially clone this database, create a new database which we can work with, and then also start the service directly within Snowpark. So what I have for this available is the service manager. Let's just to be sure that we create the new database as a clone. I will clone now this database. And while that's running, what it means is currently we're cloning a template database which is empty basically. So besides the basic structures which are necessary to run Datavault Builder, there's no actual data model in it yet. But if you would have already an environment with the data model and also with data loaded into it, by cloning it, you can then directly on your sandbox environment also use the structures which are already there. And when you start Datavault Builder, it will actually directly show you the data model as it looks on the environment which we just copied over the database from. So let's just also grant. Now the usage on this clone database to the technical rules which Datavault Builder will be using to connect to the database. And now within this template database, we actually have a procedure which in the end doesn't do anything else than filling in a YAML file, Docker Compose file, which specifies how the services will look like. Let me just quickly run this. So and basically what it outputs and also stores then is just a spec file, which tells us which images it will use, which volumes there will be mounted from Snowflake's stages. But essentially, we can just wrap this into a procedure on Snowflake so that we can define just, well, which Datavault Builder version do we want to start, what is our admin user on that environment if there isn't any yet, and further settings which we could configure. What it has now written is the spec file, and it also already has written this spec file into a stage which we call here secrets. So that means that once I want to create the service, I can then down here just say, well, create my service Datavault Builder Snowpark webinar using this spec file which I've just created. So let's just show here compute pools which are available. So as I said previously, we have already created a compute pool which we can now use. And services like we have not yet any services running. So we don't have to drop the service because it's not running. But let's create that service. And let's see what that does now with our compute pool. That compute pool which we're using, which we said where we want to create the service in, was previously just idle. Now it's actually active because we had it configured to stay idle and auto suspend, I think, after, let's see here, yeah, after 1 hour, so it's idled. But also if it would have been suspended, we have also created it with auto resume. So as soon as we send a create service request here to the service, to the compute pool, it will just resume that compute pool. Now, regarding the service, it tells me here, well, it is already running. We can also now query the detailed service status here. Actually tells me the different services which make up Datavault Builder are running and ready. And what we can also check here is actually the logs from the different services, from the different containers within the service. We see here, well, it started and up and running. So last thing what we need to check here is then I have created the service with an external access integration. So now I have the endpoint which will be made available directly with from Snowflake, so I don't have to take care of that. But what I can do is just ask Snowflake here, show me the endpoints which it created here. What we see here, it's still provisioning the endpoint. Let's just recheck that. And now we have an endpoint available. And let's see if we have now an environment running. And now what you notice is that actually when we try to access our Datavault Builder environment, it's actually prompting us for authentication with Snowflake. And that's if you recall the slide from the architecture, because Datavault Builder, the service is now running within the Snowflake environment. So it's actually running behind the Snowflake authentication proxy, so that we can now actually just authenticate using our Snowflake user. Let's just do that once. Assigning to Snowflake. And actually what Datavault Builder will do, it will notice that we are running within Snowflake, and it will retrieve from Snowflake directly that there is a user. It assumes basically because it was authenticated by Snowflake already, that the authentication was successful because the application can be reached. And Snowflake Snowpark environment is actually also passing in which user is using this environment. So Datavault Builder actually knows and is aware that I am logged in with my Snowflake user. So you don't have to set up actually additional accounts here, but by giving access to a certain user to that endpoint, to that service, we can manage then the login authentication here, or the setup of the user here, which are allowed to access the environment. So, as I said, it was an empty database. What I can now do is, let's show here just a demo hub. And let's quickly switch back to refresh databases here. Yeah, now we have the Snowflake webinar database. And actually, this year, the demo is showing up. And I could also continue adding more just to show you that I didn't just create a hub which was actually already there. So let's just reload here. Yeah, we see here it's actually integrated with this database which we created as a clone previously. So in sum, what we do here is really handing over the power to start new environments. So to do it as easily as using Snowflake, essentially it is. So creating the new services is a matter of executing SQL statements or SQL commands here in the environment. And if I have the privileges to create that service, I can, without having to worry about setting up infrastructure, without having to worry about ordering VMs or any clusters running Kubernetes, I can just then deploy Datavault Builder within Snowflake infrastructure and have a new sandbox here available. I don't know when I started, within 10 minutes. And of course, because I was explaining this, it took longer than actually would have taken if I just executed commands. So the question is, again, why does it work? Why did it work with just spinning up this environment? And the key here, I mentioned this previously, is again, that Datavault Builder is stateless. So in a classical modeling approach, we do work against the metadata repository, and from there we generate the implementation. So meaning there's a certain kind of disconnect between the current representation in our metadata repository and the actual implementation, which is on the database. And with Datavault Builder, we actually have this bidirectional sync. So we read again, or the essential truth about the state is what's currently implemented on a certain environment. And by just cloning in the database, we can thereby also clone a certain state and have that available to directly then continue working with and applying our changes on top of it. Now, why does this help now scaling? Why is it so essential that creating new environments must be as easy as possible? And that's because you most often not just have a productive environment, but at least as well a test system and a development system. But in addition, if you want to follow a distributed development approach, you potentially even have more environments. So for a certain feature, for a certain story, you create additional environments where you just create a certain change and you test a certain change prior to then integrating that on your integration dev or bringing this to the test environment prior to releasing it, so that you can, on a small scope, apply changes and bring them into stable form before actually combining it with other changes. And that's also where Datavault Builder can then support again. So it's not just a setup here, which is essentially key to success. But also, once you have this cloned environment and you apply your changes, of course, you cannot just bring these changes into your original environment by just replacing it. But what you can do in Datavault Builder is you can then compare the states of these two environments, compute the differences, and also then compute changes to align these states, to roll out these changes onto a different environment. Now, you cannot just do this once or just do it directly by comparing different environments, but you can also integrate this with a Git-based development approach so that you can then essentially have a very controlled fashion of deploying changes onto the different environments prior to rolling out a package onto the release. And now I just noticed that the other camera is on. And I'm always looking into the wrong camera. So my apologies on that one. But just with that said, how can it in the future be even more simplified? Because we skipped now an essential part, and that's this one-time setup, which is still required then, which is required to bring the images into a Snowflake, how we can even ease that in the future. So just handing over to Carson on that part.
Thanks, Beat. Just before I start with the Snowflake native app, there is a question from Subramanian regarding the Docker part and the security part. So regarding Docker and licenses, on the Snowflake side, all you pay for is basically, again, the consumption as you used to. In this case, consumption of the compute pool, as long as it's running, it'll consume credits. If you turn it off or basically put it to sleep, it won't consume credits. So that's one thing. Again, we have different sizes. I think you maybe briefly saw it when Beat showed it, the pools available. There was an XS pool. That was the one that was suspended. And then there was the S pool that was, I think that's the one that we were using then, that was active. So there are different sizes, different configurations of CPU, RAM, and in this case, there was no, exactly, show the compute pools. You can see that we have that's a CPU S pool, which means there's no GPU in that. GPU would make it, of course, more expensive. And the XS and it's not that you cannot compare on a credit consumption point these XS with the warehouse XS. These here are even cheaper than the warehouse XS. It's a very, very light approach. Good. Security-wise, the thing entirely runs in Snowflake. As you saw, you have to, in order to even get to that service that was created prior to that, you have to log into service to Snowflake. So that security of Snowflake that you have probably already, or your security team already went through to make sure it's all secured and everything, that's still the case. The advantage even is if you use not Datavault Builder, because Datavault Builder is stateless. The state is already stored in the database and will never really leave the database. Unlike if you had a repository with your application that you would be using that would be running outside, then your metadata would actually sit outside the secured Snowflake environment. And bringing it to Snowpark Container Services means everything stays in that secured environment. So I would say a tick in the box, that's also done and good. Talking about native apps, what we just saw, so we have the Snowpark Container Services, right? That's great. And we just saw a couple of scripts, and that was just the script, not even setting up the initial compute pools and stuff like that, but actually the second part of that deployment. Nevertheless, it's SQL, and no user really, except for the SQL data engineers, but a business user does definitely not want to use SQL from the command line. So that's why we also several times back created this concept of native apps, Snowflake native apps, to allow customers in general or users of the platform in general to package up logic and make it available and distribute it to other participants, be it within the same account to a different, within the same organization to a different account. So your finance department has created something nice that it wants to give to the sales department, for example, as a type of logic, whatever, just as an example. Or you want to sell a certain type of logic to somebody else because you want to monetize on that invention that you did. That could be scripts, and that's all good, but your users will probably not like that. So this native apps, I think you can skip the next one and go immediately to the one after next, because that's enables you to basically build logic, visualizations, whatever is needed on the Snowflake platform without having to provide any additional infrastructure to run that application. It runs inside Snowflake. The ability to actually distribute it very easily and quickly. You can even bring it to the marketplace and deliver it securely to your clients or to the other users. So that's the idea behind the native apps. That has existed already before we even introduced Snowpark Container Services. And so what's coming now is the ability, the combination of Snowpark Container Services and native apps, meaning you create your container, you create everything, your setup script, etc., and then you can package it up in one native application that you can then put onto the marketplace, or put on the marketplace or a private listing, all those things that are available in Snowflake, and hence make it available to other accounts, to other users very quickly and very easily to use that. That means, for example, in the Datavault Builder case, there will be a little native app that basically just takes care of the initial setup to create the compute pool, upload the Docker images into Snowflake, and stuff like that. So the very, very simple things, defining the service, and then basically have a second button that then does those steps that Beat just showed to create this clone of this template database and define the service, and off we go. That is basically what the native application state is, and especially the combination of native applications with Snowpark Container Services. And the native applications, that we purchased Streamlit a while ago. So you have Streamlit, for example, available to then also create visualizations. You see them here as some screenshots from other vendors that have created already these types of applications. Not in these cases, not necessarily using Snowpark Container Services, but just an application that visualizes, takes your data, visualizes it, and the logic runs in your account. As a vendor, you can always, you're in full control of what can be used and done with your logic. You cannot access, however, the customer's data, so that is also secure. So that's the native app, and that's basically what will be probably coming with Datavault Builder. I guess the outlook, Beat, you can skip the next 3 slides. I guess that's just a very brief overview of how to create an app and then put it into a marketplace, which is very simple. Everyone can start with that. And that's, develop, use any language, publish it, and monetize it. And of course, you can maintain it as a provider. But so that's the basic 3 steps now bundled up with Snowpark Container Services, where you basically have that app plus your container, your Dockers, and you're ready to go.
Okay, so you already took ahead a little bit of what I was going to say about where the road is going with Datavault Builder as well. So as initially said, there is actually 2 parts to spinning up the environment on Snowpark, and that's once the setup, which you have to do initially to get everything in place, and then for each environment, which is the part which I've just shown, so which then actually is just to replicate. And what I've just done actually is just to stop that service again and just remove it. Again, it's just SQL command, so that environment is not just gone again. But where we are actually going here is exactly this. So instead of having to manually configure the setup yourselves to create your imagery repository, to create these integrations, to manage the pool, install this template database, and so on. The goal here really is to bring this then, of course, as well into the native app store. We cannot say here the timeline yet, but we're certainly working on it. So essentially what it means, I think, Carsten, you have summarized it very well. By the push of a button, you can basically install a new environment, or by the push of two buttons, you can install a new environment. And that's really what's going to make it very straightforward then to make also your data team capable of creating the new sandboxes, creating new environments, and really work in an agile approach using sandboxes. And that's really as well then what we have in regards to benefits here. We can really very quickly start new environments. I've shown this here with our test or demo account. So that environment was running within minutes. We didn't have any infrastructure set up here involved. Once you have these initial scripts, of course, in place, and the big benefit, and that's what already Carsten addressed as well regarding the security context, it's all running within Snowflake. And with Datavault Builder, which is also not exposing any metadata about your actual environment, it means also that not only no data leaves your environment, but also no metadata leaves your environment on Snowflake. And in regards to scaling, then of course the benefits here is really you can benefit even more of the zero copy clone feature, because zero copy cloning, you can work with data which you already have in a certain environment, clone it, and now in addition with creating the sandboxes in Snowpark, you can not just clone the database with a statement, but you can also start then the corresponding service just with a set of statements. And as I've done with the procedure, which is just preparing essentially the YAML file, you can of course also just create your procedure, which is even more simple. So you don't have to run this scripts, which I've just shown you one by one after one another, but you can just script that. It's, again, very simple to start new sandbox. And by enabling the usage of the sandboxes, you can then really make use of a Git flow-based approach. So having multiple sandboxes, of course, means you need to also then integrate changes. And that means that you will need to, at least at a certain scale, bring in a Git flow-based or a good code versioning process and the continuous integration process to have a tested state then being deployed onto the productive environment.
In case you have additional questions, please do not hesitate to contact us. We're more than happy to answer anything that pops up and support you. With that, I just learned that Germany leads 1-0. Sorry, we have.
I was just about to say.
We have the German European Championship going on in soccer or football, wherever you are and whatever you name it. So, and Germany plays right now. It's halftime, so I'll be ready for the second half. And from my side,
anyone interested in soccer, thanks for joining our webinar, and of course everyone else too. Thanks for all the questions as well, and looking forward to hearing from you. Thanks also, Carsten, for being with me today.
Thanks for having me. Cheers. Bye.
Bye. Thanks.